Now the next part is combination of resistors. How can we combine different resistors or the resistors? Resistors can be combined in series as well as in parallel. Series means like this. This is called a series combination, in which all the resistors are combined in straight line, in a straight wire. And the parallel combination is, you can imagine that if we passing the current through this wire, the current will be same in all these resistors. So in series, combination, the current in each resistor is same. And what is the meaning of parallel combination? If we combine the resistors in parallel, then the current passing through it is divided into some parts. Suppose we are connecting the two resistors, then the current is divided into the two parts. And suppose we are connecting the three resistors, the current is divided into the three parts. So in parallel combination, current divides, but in series combination, the current is saved from the circuit. Okay? So now, what is the total resistance if we combine the resistors in a series? So these are few resistors. I am taking three resistors here. These are three resistors. I am combining it with the battery, connecting it to the battery, and a P. Suppose these resistors are R1, R2 and R3. And if we connect these resistors with the battery, it means the current will start flowing to it. The battery having the potential difference of V. And the current passing through the circuit is I. So the potential difference is V and the current is I through the circuit, and these are the three resistors R1, R2 and R3. And now we want to find the total resultant resistance of the circuit. We want to find the total resistance, or we can say the resulting resistance of the circuit. So first, one more thing we should know that in parallel combination, in series combination, the potential difference divide into three resistors. Suppose this is the total potential difference of the circuit, and let the potential difference of this R1 circuit is V1, for the second one is V2, and for the third one is V3. So all the three resistors having the same current, but the potential difference divide into three parts. Which means if you connect the resistors in series, the potential difference divided. Suppose you are connecting a bulb in a series combination. You know, at your household, the wiring is parallel. Why parallel? Because in parallel combination, the potential difference is same. It means all the appliances will work at 220 volts. But if you connect the appliances at series, then the potential difference will divide. Okay? So in case if you are connecting the resistors in series, the potential difference will be divided into three parts. Let they are V1, V2 and V3. Okay? Now for the first resistor, that is R1, we can say that V is equal to I into R1. Since the current in all the circuits are same, all the resistors are same, so we can say the V is equal to the V1 is equal to I into R1. V1 is the potential difference of the first resistor. So V1 is equal to I into R1, and V2 will be equal to I into R2, and V3 I into R3. So let's add these equations. We will get that V1 plus V2 plus V3 is equal to IR1 plus IR2 plus IR. We can take I as a common here. R1 plus R2 plus R3. And what is the total potential difference of the circuit? That is V. We can say that V is equal to V1 plus V2 plus V3. These potential difference of whole circuit is divided into three parts: V1, V2 and V3. And the sum of these potential differences is equal to the total potential difference of the circuit. So we can say that V is equal to V1 plus V2 plus V3. Now we can take in place of V1 plus V2 plus V3, we can write it like V. Now V is equal to I R1 plus R2 plus R3. if the resulting resistance of both the circuits are, let the resultant resistance of both the circuits are, so we can say that V is equal to I into R, where I is the current in the circuit and R is the resistance, total resistance, so we can say equivalent resistance of the circuit is equal to I R1 plus R2 plus R3. I will cancel out the die and we get R is equal to R1 plus R2 plus R3. So this is the resultant resistance if you combine the resistors in series combination. Is it clear? So Raga will logo that resistors in series. Resistors in series. No. You have to write the heading. Resistors in series. Make this diagram in your notebook. This one. There are three resistors R1, R2 and R3 which are connected in series and having the potential difference of V1, V2 and V3, and the total potential difference of the circuit is V and the current in the circuit is I. Please make this diagram in your notebook. Only this one. Only this diagram in your notebook. Draw it. Draw this diagram in your notebook. Pass first problem. Done? Draw this diagram in your notebook. Now, write a statement that three resistors R1 and R2 and R3 are connected in series. That three resistors R1, R2 and R3 are connected in series. Are connected in series with the circuit having the potential difference of V volt. With the circuit having the potential difference of V volt.
Potential difference of
V volt. The potential difference of the circuit is V. Of V volt. Let the current in the circuit is, don't write it again, let. Like don't write it. The current in the circuit is I. And the potential difference of R1, R2 and R3 are, and the potential difference of R1, R2 and R3 are V1, V2 and V3 respectively. V1, V2 and V3 respectively.
and the potential difference of
Resistors R1, R2 and R3 are V1, V2 and V3 respectively. Done? Now write down from next line. V is equal to V1 plus V2 plus V3. And write it like equation 1. V is equal to V1 plus V2 plus V3 according to equation, this is the equation 1. Now we are looking at according to Ohm's law. Write down here according to Ohm's law. According to Ohm's law. Now please write down this equation V1, V2 and V3. V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR2. You can write the equation second, third and fourth. If you want, you can write the equation second, third and fourth. The equations. Now write down by adding the equation second, third and fourth. By adding the equation second, third and fourth. By adding the equation second, third and fourth. Now please write add V1 plus V2 plus V3 is equal to, now please write all this thing in a notebook. बारह पुनः यहाँ से लेके यहाँ
By adding second, third and fourth.
Fourth equation we get from here, write all this thing in a notebook. Done? Done? Now let's discuss few questions. Few questions related to this series combination. The question is, please draw it in a notebook. This is the first question. Draw it in a notebook. And the question is, first part, you have to calculate total resistance. Write in the question, calculate. First one is total resistance. Second is total current. Third is potential difference across 6 ohm resistor. These are the 3 parts we have to calculate. First one is the total resistance. Who is going to answer me what is the total resistance of the circuit? That's good. What is the one, Rishabh? The answer?
R1 plus R2.
It will be
6 plus 4.
equal to
10.
10 ohm. Yeah, this is the total resistance of the circuit. So we will use the formula R is equal to R1 plus R2. It means 6 plus 4 will be equal to 10. What is the total current? Total current. Raise your hand. Rishabh, will you answer this question? Total current in a circuit. Total current in the circuit. Yes. Yeah, we can use the formula that is Ohm's law. According to Ohm's law, I is equal to
Volt upon
V upon R. V is how much? 20 and R is 10. So we will get 2 ampere. Okay. And last part, who's going to answer this part? The potential difference of 6 ohm resistor. Raise your hand. That's not the correct answer. Raise your hand for answering yes.
Right.
Tell, how will you calculate it?
And for I am potential.
We know